So there's a new concept that I'd like to discuss that's related to a lot of the material that we've discussed in this unit. And to bring that new concept up, I want to bring up mole again. So a mole is just another way of saying one group of 6.02 times 10 to the 23 things. A millimole is 1/1000th of a mole. So in the same way that a millimeter is a meter broken into 1,000 pieces, a millimole is 1 mole of things broken into 1,000 even pieces. So millimole is abbreviated MMOL, and basically what it means is 1/1000th of a mole. So I want you to keep that concept in mind, 1/1000th of a mole, for the new idea. And I also want you to keep in mind electrolytes. So if you remember, electrolytes are basically ions that are floating around independently in a liquid that allow you to sort of turn on this fancy light bulb here. So they can help conduct electricity, which is why they're called electrolytes. There's a new concept that I want to introduce called an equivalent. So an equivalent, and the abbreviation is EQ, is the amount of an ion that provides 1 mole of electrical charge, either positive or negative electrical charge. It doesn't matter. So if you have 1 mole of positive charges, that's 1 equivalent. If you have 1 mole of negative charges, that's also 1 equivalent. If you have 2 moles of positive charges, that would be 2 equivalents. So hopefully you could have a sense of what that is now. And just to give you a better sense of why this is being stated in kind of this weird way, 1 mole of electrical charge. If I had 1 mole of sodium plus 1 over here, the electrical charge is positive 1, and I would have 1 equivalent. However, if I had 1 mole of calcium 2 plus, if I had 1 mole of these, because there's a charge of 2 plus for every one of these, then I would have 2 moles of positive charges if I had 1 mole of calcium 2 plus. So if I had 1 mole of calcium 2 plus, I would actually have 2 equivalents of electrical charge. And again, just to give you a different example, iron can come as charged at +3. So if I had 1 mole of iron, I would have 3 moles of positive charges, which would mean I would have 3 equivalents of electrical charge. And this is also true for negatively charged ions. So chlorine -1, if I had 1 mole of chlorine, I would have 1 equivalent of electrical charge. This is called sulfate. If I had 1 mole of sulfate, because each sulfate has a charge of -2, I would have 2 equivalents of electrical charge. And a milli equivalent is basically 1/1000th of an equivalent. So the idea is that if I had 1 millimole of sodium ions, I would have 1 milli equivalent of electrical charge. And if I had 1 millimole of calcium, because it has a charge of +2, I would have 2 milli equivalents of electrical charge. And the reason that milli equivalent is being emphasized here is that this actually tends to show up in medicine, and the amount of electrical charge to actually have 1 equivalent is huge. And in medicine, at least, you're almost always dealing with milli equivalents, which means 1/1000th of a mole of electrical charge. So that's why milli equivalent and millimole were introduced earlier. So where does this actually show up in medicine? Your body, your bloodstream needs electrolytes, and it needs very specific amounts of electrolytes. So when people in hospitals are replacing bodily fluids, basically blood, by IV, you will usually have replacement solutions that have very specific amounts of equivalents, very specific amounts of ions. There's a very common replacement solution called Ringer's solution, and if you look at the ingredients on Ringer's solution, the ingredients, at least for the ions, are often given in milli equivalents per liter. So just to give you an example, for a common Ringer's solution, you have sodium ions, and the amount of sodium ions that you have turns out to be 147 milli equivalents for every liter of Ringer's solution. And For potassium ions, it's 4 milliequivalents per liter. For calcium ions, it's also 4 milliequivalents per liter. And for chlorine, there's also chlorine mixed in there as well to neutralize all of these, and the amount of chlorine is 155 milliequivalents per liter. What that means is that you have, in this case, in the case of chlorine, you have 155 millimoles of negative electrical charge for every liter of liquid. And the other thing to point out, and I'm pointing that out on the bottom here, is that the milliequivalents per liter of the cations, of the positively charged ions, has to equal the milliequivalents per liter of the anions. So if you add all of these up, 147 plus 4 plus 4, it should equal 155, because the negatively charged ions have to neutralize the positively charged ions. And so that's basically, you may not realize this, or you may realize it, but these descriptions are just a fancy way of describing concentration. So this is just another way of describing concentration. In this case, they're basically describing it by how much electrical charge you have dissolved in a certain amount of volume, dissolved per liter. You have 147 millimoles of positive electrical charge dissolved for every 1 liter of Ringer's solution, as far as sodium is concerned. And you can do that for any of these other ions here. So this is just a fancy way of describing concentration that you might actually come across in the real world. So that's milliequivalents and equivalents. What I'd like you to know is I'd like you to know what a millimole is. I'd like you to know what an equivalent is. That's 1 mole of electrical charge. Doesn't matter whether it's positive or negative. Know what a milliequivalent is. It's 1/1000th of a mole of electrical charge. There's one last concept, and I'm not going to spend a lot of time on this. In case you have not heard this term used before, I just want to introduce the word dilution. Basically, dilution is a way of reducing, of lowering the concentration of something dissolved in a liquid. And the way that it's typically done is by increasing the denominator, increasing the amount of solvent that is doing the dissolving. So here, this is an example shown from your book. They are showing some material that apparently gives a red color to this liquid, and it's at a high concentration. So they're saying if you could zoom in and look at the molecules, you would see a lot of these red molecules sort of bouncing around in the fluid near each other. However, if you add more volume of your solvent, more of the stuff that does the dissolving, you can see that this liquid becomes less red. And what you're doing here is you are diluting your solution. So now the concentration gets lower because you're increasing the amount of solvent. You're increasing the denominator in the concentration equations that we were working on in the previous sections. So if you do that, and you could zoom in on your diluted solution, which has less concentration of solute, you would see fewer red molecules in the same amount of space, because there's more liquid dissolving them. So that's what a dilution is. It's just reducing the concentration of your solution by increasing the amount of solvent. And that is it for Unit 7. I will see you, or probably won't see you. You will hear me at the beginning of Unit 8 again.